In this lesson, the instructor uses inquiry-based learning model so that the students build a conceptual understanding of the law of sines and cosines.
All right, so we're going to get started. We're wrapping up trigonometry today, just with two little topics.
The instructor asks basic questions to activate students' schema and knowledge relevant to the topic.
Okay, more specifically, what type of triangle?
Right triangle.
Okay, is the right triangle the only triangle out there? No. So we need to know more. What happens if it's not a right triangle? So what other triangles are there? Isosceles, equilateral, scalene. Okay, so in order to cover the non-right triangles, we have what's called the law sines and law cosines. So in your groups, I want you to talk about why do you think the law cosines is a stronger statement than the Pythagorean theorem?
In inquiry-based learning, it is essential for students to have uninterrupted time to grapple with the concept and confer with other students to build their understanding. Notice that the instructor monitors students closely without interfering in their process of concept formation. While the instructor is monitoring, he is gathering information about the student's concept formation.
I actually think it does end up being one triangle. It's that distance. At least I'm not really sure. I don't do so well with pictures.
I know, no one does. That's the point of this. Without pictures. Okay, the plane went this way.
Yeah.
The other plane went this way.
Yeah.
If a misconception is consistent among the students, it is important to clarify in a timely manner. In this lesson, the instructor waits for an opportunity to clarify the misconception based on what he has observed while monitoring the students.
So when we're using angles of elevation and angle of depression, we always assume that someone is looking straight ahead at the horizon. Okay, so this is our 0 degrees. Just like on the unit circle, always measured across the x-axis.
Now the students return to the problem to apply what they have just learned.
Except I have this B Matteo in this picture. I don't know if that makes a difference. Yeah, it does, because like your angles aren't right. I have 68 down here and 34 up here.
In the IBL model, students share their work to bring closure to a problem. We use the student's work rather than the teacher's so that the student learning process is evident and to create a student-centered environment. In this lesson, the instructor is using student work even though he is presenting the problem.
So in this problem, we know the angle is 160. Okay, so the side that is opposite of 160 is written here. We're trying to solve for C on this one, so we don't know it. On some problems on the homework, you're going to know this, and you're going to have to use algebra skills to solve for the angle. So on this is one of the easier problems. When you know everything on one side, you get to type it all in the calculator, square root it, 128. It's the largest angle of the triangle, so it should be opposite of the longest side. So that answer is reasonable, and most of the ones that got through got that answer.
Now that the students have developed the concept, the instructor extends student thinking by asking deeper questions.
So before I go any further, I want you to try to draw what that means. And I want you to try to think, why can I not only have one triangle? If I gave you an angle that doesn't move and two sides that are a fixed length, why is it not possible to only have one triangle?
It's cut diagonal.
Yeah, like I drew a diagonal line, and then I just connected it like that.
I have no idea.
Conclude the IBL lesson by setting up extension questions for students to work with outside of class. The instructor may also assign practice based upon his observation of student mastery of the concept.
So if I gave you all the sides, and you have to do that on the homework, you could solve for the angle. And no matter what, you need 3 bits of information. 4 is better, 5 is good, 6 you're done.